Good day everyone. In this video, we are going to talk about the inverse of logarithmic functions and exponential functions. In our past lessons, we have learned that the logarithmic function and exponential function are inverses of each other. So if we have, let's say, for example, f of x is equal to b raised to the power of x, and we know that this is an exponential function. So to get the inverse of this function, so the inverse of b raised to x would be the logarithmic function, which is log base b of x. And similarly, if we have a logarithmic function, let's say g of x is equal to log base b of x, then the inverse of g is equal to b raised to x. Okay, so let's have some examples. Find the inverse of the following functions. So number one, we have f of x is equal to 2 raised to x. This is an exponential function, and we know that its inverse would be in the logarithmic form. So what we can do is to have the variables y and x first in our equation. So I can write this as y is equal to 2 raised to x. So we are going to interchange the variables y and x. So x is equal to 2 raised to y. Then we are going to solve for y in terms of x. So transforming this into its equivalent logarithmic form, we have log base 2 of x is equal to y. And transforming y into f inverse, so we have our final answer to be f inverse of x is equal to log base 2 of x. Next item, we have g of x is equal to 10 raised to x plus 5. So again, I'm going to rewrite this as y is equal to 10 raised to x plus 5. Then what we can do is to transpose plus 5 to the left side of our equation. Okay, but before that, we are going to interchange our variables first. So this becomes x is equal to 10 raised to y plus 5. Okay, so we're going to solve again for y in terms of x. We have x minus 5 is equal to 10 raised to y. Okay, so getting the logarithmic form of this, we have log base 10 of x minus 5 is equal to y. So again, to get the inverse, we just use our proper notation. So si y, gagawin nating g inverse. Okay, so g inverse is equal to log. So since this is a common logarithm, our base is 10, so we can opt not to write the base 10. Okay, so this is log of x minus 5. Next item, we have h of x is equal to log base 5 of x. So this is a logarithmic function, so the inverse is expected to be an exponential function. So again, let's rewrite this. Y is equal to log base 5 of x. Okay, interchange the variables. We have x is equal to log base 5 of y. So we are going to isolate or solve for y. So how do we do that? We transform this into its exponential form. So we have 5 raised to x is equal to y. So again, for formality, we are going to change y into h inverse. So h inverse of x is equal to 5 raised to x. Okay? And last item, we have k of x is equal to the log of x plus 1. Okay? So I'm going to change again k of x into y. So y is equal to log of x plus 1. So this is a common logarithm, so our base is 10. Okay, so interchange the variables. X is equal to log base 10 of y plus 1. Getting the exponential form of this, we have 10 raised to x is equal to y plus 1. Therefore, y is equal to 10 raised to x minus 1. So again, we are going to change y into k inverse. So the k inverse is 10 raised to x minus 1.